we move ahead to the next module of stationary waves. Students, in this module, we are going to learn about the numericals which are based on the concept of beats. Remember students, this concept of beat numericals are the most important ones. Reason being, because these numericals are asked not only in board examination but in entrance as well. So we'll study the numericals on beats, and in that we have the first example, something like this. It says that there is a sonometer wire 100 centimeter long which produces a resonance with a when the length is increased or decreased. In this case it is given as decreased by 10 centimeter, 8 beats per second are heard. Find the frequency of the tuning fork. Now you need to determine the frequency of a tuning fork. But let us first write down what is the given data. We know that the original length is given as 100 centimeter. We know that the length is decreasing by 10 centimeter. That means it is 100 minus 10 centimeter, and that will come out to be 90 centimeter. Now students, we know that as the length 2 is less than length 1, means the length decreases, then the frequency must increase. And how do I know that? We know that the frequency was inversely proportional to length from the laws of vibrating string. And so if the length decreases, the frequency must increase. That means the frequency in the second case will be greater than the frequency in the first case. That is why N2 is greater than N1. And how many beats per second are heard? It is 8 beats per second are heard. That means the difference in the frequency is 8 beats per second. That is N2 minus N1 is equal to 8 beats per second. Now many students must be wondering why it is not N1 minus N2 and why it is N2 minus N1. Students, the simple reason is that because N2 is greater than N1, and that is why N2 minus N1 is 8 beats per second. Now you need to find out the frequency of the tuning fork. Students, remember in the question it is given that 100 centimeter wire produces a resonance with the tuning fork. That means when the wire is having frequency N1, the frequency of the tuning fork is in resonance with it. That means the frequency will remain one and the same. So I can say that N1 is actually to be determined. That is the frequency of the tuning fork. What is the formula? We know that the formula is N is equal to 1 upon 2L under root of T by M. From this relation, we go ahead to the solution. In solution, we know that N is 1 upon 2L under root of T by M. And by this, I can say if T, M and 2 are constant, N is inversely proportional to L. So can I say for the first case, N1 is inversely proportional to L1 and N2 is inversely proportional to L2. Overall, I can say N1 by N2 is equal to L2 by L1. So N1 L1 is equal to N2 L2. Students, we know the value of length, that is L1 as well as L2. So substituting those values in this equation, I'll get 100 N1 which is equal to 90 N2. So can I say N2 is 100 upon 90 N1, and on cancelling I get N2 as 10 by 9 N1. As we know that L1 is greater than L2, we have concluded that N2 must be greater than N1. So N2 minus N1 comes out to be 8. Now students, we know the value of N2. What is the value of N2? 10 by 9 N1. Can I take that value and substitute in this equation? Yes students, I can. So that will be 10 by 9 N1 minus N1 which is equal to 8. Now when I take N1 common, it comes out to be 10 by 9 minus 1 which is equal to 8. And on solving this, I get N1 as 9 multiplied by 8. The answer comes out to be actually 72 Hertz. So the frequency of the tuning fork will be 72 Hertz, which is the frequency of the first length of vibration as well. So students, with the help of this module, we studied the problems which are based on the concept of beats. Thank you.